All right, so yeah, I wanted to give a behind-the-scenes look at the kind of data analysis we're doing for the upcoming Punk Vault. So this is the data we have here. It starts out with the assets. So this is each of the Punk tokens and their attributes that describe them. So these are binary for each of these attributes, and then type, gender, skin tone are categorical. And then we have all the historic transfer data on every single Punk. So what price it traded at what time. And so to get time out of the equation here, we'll convert that into a percentage of market cap. So that's another way to think about that is how is the Punk trading with respect to other Punks in that time frame. So this is the distribution of that price, and you can see it's very right skewed. Down here in this long tail, it's probably all the rare Punks that are trading for much higher value than the average Punk with the typical traits. So to turn this from a regression problem into a categorical problem or a classification, we bin the prices into deciles. So this is what it looks like after we bin them. So these 0 decile or 1 for the first decile will be the lowest trading Punks, and the 10th decile will be the highest trading Punks. Okay, now let's look at how the features decide the price that it's trading at. So we'll go through a series of violin plots, and first I'll just say how to read this exactly. This shows the distribution of the price given a certain trait. So this white dot here is the mean. The bars represent the standard deviation in each direction, and then the height is the count. So it's kind of like a histogram or a kernel density estimation. So we see that the male Punks are trading slightly lower than the female Punks. There's this, it seems to be like there's a grouping around the 10th decile for female Punks, and that doesn't exist the opposite trend for male Punks. Let's look at the same kind of plot for number of traits. So for 2 to 4, it seems like it's pretty evenly split. But if your Punk has 5 or more or 1 or less traits, they'll be centered around the higher deciles. Those seem to be the desirable Punks. And we can see here how that correlates to rarity. Only 8 Punks have 0 attributes. Only 300 have 1. And very few have 5 or more. And it seems like most have 2 to 4 unique attributes. For Punk type, the vast majority are human, so we expect that to be pretty evenly split. And if it's not human, it's almost guaranteed to be trading in the higher deciles. Zombie, ape, or alien. Now let's take a look at the most rare attribute here. So the most rare is the beanie. Only 44 have the beanie. And as you'd expect, they're trading almost exclusively in the 10th decile. And if you don't have the beanie, it's just all the Punks, so we expect this to be pretty uniformly distributed. And the most common is the earring. So the opposite end of the spectrum from the beanie. Almost 2,500 Punks have an earring. So it's almost, it brings down the price, it seems. So 1 is the variable for has earring, and it seems to be centered around the lower deciles. So now we can take a look at how different pairings come together. So let's look at nerd glasses and cigarette. Those are pretty common traits, so we don't expect them to have too much price influence by themselves. But what happens if they're paired together? So neither is just the rest of the Punks. We expect this to be uniform again. Only cigarette, trending quite low, I think. Only nerd glasses, pretty hard to tell, but it's centered around the middle again. But if we look at the combination of nerd glasses and cigarette, it'll trend towards the higher deciles. Average seems to be about almost 7.5 decile. So this is just a very human way to go about it. You can look at these graphs and make and come up with signals to trade on, or we can go into some kind of clustering. So using machine learning. So we run this and we find out which type of attributes are often found together or clustered together. And I think Curtis showed one version of this graph here. So this graph, there's a lot of information, so it might not be intuitive right away. But so the punks are clustered, and all these clusters from, I think this is 0 to 100, and they're just labeled with their cluster ID. The y-axis is the average decile. So that's most important thing here is that the higher it up on the graph, the more expensive the punks are trading at. And then the cluster variance is the x-axis. So the ideal cluster is in the top left here, with a low cluster variance and a high average decile. And the size of the bubble corresponds to how many punks are in that cluster. So we'd want a big cluster in the top left. So let's take a look, and there is a cluster right here with an average of 10. And so it finds the best one. The best one is cluster 35, and the average decile is 10. So let's take a look at what it gets there. So we see that every punk in this cluster is female with medium skin tone, black lipstick, and a pilot helmet. And those are always trading at the 10th decile. So if you find one of those outside the 10th decile, it's probably a good opportunity to buy. But we don't have too many insights from this because it's such a small sample. There's only 3. It's a rare opportunity to capitalize on. So let's go back to our graph here and pick a better example, maybe like 53. Like very similar high decile, but just more assets in the cluster. So let me run it again for 53. And we see that the representative traits of this cluster are females with dark skin tones and orange side. Orange side is the hairstyle. Right here. A pretty rare one too, only 68. So if we find something in this cluster that's trading outside or lower than the average decile, which ended up being 9.9, so pretty much 10, that'd be a good buy opportunity.